or A bar. So they all talks about A does not happen. And what does that mean? Let's say we have this sample space and my event is probability of A is not probability. Let me just say that event A is 2 in 3. So what is my probability of A? I know that 2 is 1/6 and 3 is 1/6. So 2/6. That is my probability of A. Now if I want to find the probability of A complement, so that means what I have other than A. So that is 1 minus probability of A. And similarly, you can do for probability of A is 1 minus probability of A complement. So if you know 1, you can find the other. And if we are looking for complement here, I can do 1 minus 2/6, which is 4/6. That is my probability of A complement. And if you know the complement value, you put 4/6 here, 1 minus 4/6, you get 2/6. So this is also one of the rules. When we say complement, complement talks about everything other than that. And since we say that complement, we say probability of A plus probability of A complement is my probability of the sample space. So this rule comes from here. And think about that. Probability of A and its complement is my entire sample space. And what is the probability of sample space? 1. That is my second rule. 1. So if I am looking for A, I will move this side and this will be this rule. And if I am looking for A complement, then I would move PA here. So these things you don't need to memorize. They are just coming straight from the first two rules. First rule says that probability of an event between 0 and 1. And second rule says that probability of the sample space is 1 whole. And when I look at these two, and let's look at a Venn diagram, the graphical representation that you see. I'm writing wedge diagram. And let's say this is my sample space. So the probability of this rectangle is 1 whole. And if this is my event A, if I'm talking about this event A and the probability of this event is 30%, I know that probability of A is 30%. What is the probability of my A complement? So when I'm saying probability of A is 30%, that means this whole is 30%. I convert it into decimal because I know I'm looking for 1 whole. So if I'm looking for A complement, that means I'm looking for everything except this part. So complement of A is everything except this in this sample space. So anything outside this is my complement. And how much will the probability of that be? I know that if this is 30% and this whole thing is 1 whole, so I can find the complement, which is probability of the sample space minus my probability of A, this whole, which is my sample space. And if I subtract this, and I know the sample space is 1, I know the probability of this is 30%, and the complement is 70%. Questions? Everybody good with this? Okay, so here I'm talking about just one event. What happens if we have 2 events? Let's say we have 2 events, A and B. And I have another Venn diagram where I have 2 events. So I'm talking about 2 Venn diagram. in the first Venn diagram, I'm talking about two events A and B. And in the second diagram, a second Venn diagram, I'm talking about two events A and B. Do you think they are different? Or is there something common? Something similar? What do you think when you look at Venn diagram 1 and 2?
They're different because in the second one, A and B are taking up the same space in part of it.
Perfect. So they same thing. They have a sample space. They have two events A and B. And the difference is, in first, they have no common part, or they are non-overlapping event. In the second one, they have overlapping part, or they have something in common. So when you have something in common, we denote that part as intersection. We call that intersection or the common part. And we denote intersection as this symbol. Or you can think of that as upside down U. So intersection, and we also said that this is the common part between A and B. So intersection is also considered as and part. Sometimes the intersection word is not given, but it's given A and B. So when we are saying A and B, this is the common part between A and B. This is in both A and both B. And these events are called overlapping events. When we are talking about these, they have no overlapping part. They are called as non-overlapping or disjoint events. And if we see the word disjoint, not joined together. So they are disjoint, and sometimes we call them mutually exclusive events also. So like how in chapter 1, chapter 2, chapter 3, we talk about that explanatory variable is considered also. We use independent variable. We can use the word factors. Same thing. You can use non-overlapping events that have nothing in common or disjoint. They are joint. They are not joined together. They are disjoint or mutually exclusive events. So when we are talking about mutually exclusive event, their intersection, what should be their intersection? Do they have intersection?
No.
Intersection means common part. No. So their intersection is 0. So if we are talking about A and B two events, we can say A intersection B is 0. And here, A intersection B, again, there is some intersection. And once we have that information, we can plug that value and you can say that it is non-zero. So you will have some intersection when you are talking about overlapping events. Non-overlapping events, they are non-overlapping, so they have nothing in common. And if nothing is common, their intersection is 0. So this brings us our fourth rule, and which is called your journal addition rule. And this rule is very important because this rule will keep on changing depending upon what kind of events you are working with. So first I'm writing journal addition rule for overlapping events, or we generally call it journal addition rule. And journal addition rule implies that we are talking about overlapping events. This rule says that in union, we denote union as U. U, union. And opposite of U is intersection. So you can flip it and that will be intersection. So when we are talking about journal addition rule, we are saying A union B. And union means or, either in A or in B. And when we are saying intersection, we are talking about both A and B. So that is the common part between both A and B is intersection. Union, either A or B. If they have anything common or not common, I'm talking about union of A and B, A or B. And when we are saying A and B, and again, these two words are important, or and. Or talks about union and talks about common part or intersection. A union B is probability of A plus probability of B minus their intersection. And I'll explain where is this part coming from. You don't have to memorize, but this is what my journal addition rule is. Probability of A union B is the sum of the individual probabilities of each event and take out their common part. And why to do that? Let's talk about this. So when I'm saying A into A union B, so I'm talking about this and this, the union of both A and B. So when I'm saying probability of A union B, I say it's the probability of A. And the probability of A is this whole thing, right? So I wrote it here, probability of A. Then probability of B. When we are talking about probability of B is this part, right? So when I say probability of A, I took this orange part, this whole thing. And when I say probability of B, I took this part. So I'm taking this part twice. I'm including this part in A as well as in B. But when I'm looking for probability of A union B, I'm talking about this thing. So I'm talking about A union B. So that means this part is included twice when I'm writing this probability of A and B. So I will subtract one of this part, which is my A intersection B. And that's how it is here. So when we are talking about A union B for general addition rule, we are saying that it is the individual probability and take out the common part that I added twice. Once in A, once in B. So I took out one time out, and that is my A union B. Questions? So this is the general addition rule. Now let's talk about how this rule will be different or how we use the same rule for disjoint event. So now we are using two events, A and B, and using general addition rule, and that rule tells me that A union B is probability of A plus B minus their intersection. So let's see. When we talk about disjoint events, what is my intersection of A and B? We just discussed.
Zero.
Zero. So what is their common part? Their intersection is zero. So if their intersection is zero, do we need this part to keep? No. Because their intersection, they don't have anything as common. So addition rule for disjoint event is only their individual probabilities. So addition rule for disjoint events. And we are still using the same rule, a general addition rule, but we know that the intersection is zero, so we can just write it's their individual probability, A or B, either in A or in B. So it is their individual probabilities. Similarly, if you know the intersection and you want to find A union B, you can manipulate or you can move around the same formula. If I have this part given to me, but I'm looking for this part. What I do, I will move them or switch them around. And I can write probability of A intersection B is probability of A plus probability of B minus probability of A union B. And if this part comes out to be zero, you know that you are working with disjoint events. And if it's not zero, you are working with overlapping events or non-disjoint events. So these are our first four, or you can say important probability rules that we work with when we work with those probability problems. And let me come back to here to see if I missed something. So let's quickly go with these probability rules here. So any probability is a number between 0 and 1, like how I said. All possible outcomes together must have a probability 1 if two events have no outcomes in common. And if they have no outcomes in common, we are talking about disjoint events. The probability that one of the other occur is the sum of their individual probabilities that we just discussed, A union B or A or B. So be careful about the word. Sometimes union is given, sometimes they didn't give you union, it just say that A or B. Sometimes intersection is given, and sometimes the problem is in word. What is the probability of A and B? So that means we are looking for the intersection. And the probability that an event does not occur is 1 minus the probability that it occurs. And we discussed that. Where is this formula coming from? So probability of A plus its complement is the entire sample space. And this sample space probability, according to the second rule, is 1. So probability of A plus A complement is 1. And if I need to find this, I'll move this around. Or if I need to find complement, I'll move this around. So these are the probability rules that we work with. So here is an example, and its example says, show that this is a legitimate probability model, or it is a right probability model to work with. So if let's say you have this model that is provided to you, so first thing you need to check if it's a right probability model, can I work with? So it says that our preferences for vehicle colors can be related to our personality, our moods, our particular objects. Here is the probability model of color preferences. So what colors we have? We have white, black, silver, gray, red, blue, brown, others. So this is what information we have. So we have how many? 8 colors: white, black, silver, gray, red, blue, brown, others. Now it says that show that it is a legitimate or a correct, valid probability model. What's the first thing you need to check? Our first probability rule. That probability of each event is between 0 and 1. Is this between 0 and 1? Yes, yes, yes. So all of them are between 0 and 1. First thing, first rule satisfied. The second rule is probability of the sum of the sample space is 1. And can one of you check if it's 1 or not? Add everything and see if it is 1.
Yeah, it is.
It is 1. So our first two rules satisfied, and yes, it is a right probability model to work with. Whenever you are working with any probability model, make sure that you check these two. Let's say I'm using the same and it has this sign here, and then it has this sign here. So can we say that it is a right probability model?
No,
No. And why not?
can't be negative.
It can't be negative. Even though, let's say there are different numbers, you add everything and the second rule satisfy, let's say it's equal to 1, but it's still not a right probability model because it cannot be negative. So once you satisfy this, now you can find the probability of the events using our third or fourth rule. So here it's solved for you. It says that each probability model is between this, and yes, it's satisfied. Now the next it's asking what is the probability that a first person's favorite vehicle color is black or silver. So you need to just concentrate on this. Or means what? We are looking at union, either black or silver. So that's what I am looking for. Probability of black or silver. Now, my next question is black or silver overlapping event or disjoint events?
Disjoint?
Disjoint, because black is a different color, silver is a different. They have nothing in common. They have different probabilities. They have nothing in common. When you know that they are disjoint event, the formula we know for disjoint event is the sum of their individual probabilities, right? So here, the sum of probability of black and silver. And you know how much is black? This much. How much is silver? Just plug it and you get it. Questions? So first identify if it is a disjoint event or if you have their intersection part. The next one, it says find the probability that the favorite color is not blue. So there are different ways to work that. Favorite color is not blue. What is the favorite color? This is my blue. What is the percentage? So we have 7% people who like blue. So this is 0.07. What is the probability the people have other than blue or not blue? Other than blue is one thing is you add everything except blue and you get that. But again, it's a long way to go. We know our rule for probability that probability of an event not happening is 1 minus probability of event happening. And this is my blue. So people who do not like blue or the other than blue is 1 minus the probability you like blue. And you get that. And that's exactly it's solved here. So again, you don't have to go through a longer route. You can just use first four rules and you can solve the probability models. And we talk about this. We also discuss about finite probability model. And again, equally likely outcomes. We talk about this. If you have 1, 2, 3, 4, 5, 6, you roll a die, you have 6 outcomes. You assign probability to each outcome, equally likely, 1 out of 6 chance. So is this count the outcomes that occur in A and your number of outcomes. So one happen only once, so 1 out of 6. And we will do another example how the same question can be asked in a different way and how these probability will change in the next class. Independent and multiplication. So let me just quickly, actually time up. So I'll just stop here and on Monday's class, we will cover this topic and the next topic. So it's already 11:51. So I'll stop here. And if you guys have any questions, let me know. Thank you, everyone. Have a nice weekend.
Thank you.
Thank you.